So this is lesson 8.1, which is actually a review lesson, which I'm sure we all need, which is reviewing just some of the integration techniques we know so that we can start learning new techniques. But first, we got to make sure we know what we're doing here. So I'm just kind of starting with some basic things, just keeping in mind when you are integrating, some things to think about is, can you simplify it? Can you identify a U and a DU piece and figure out what form it's in? Is there some sort of algebra you can do? Kind of all those things work together. So for this first one, your U is going to be the whole denominator, e to the 2x. And then your derivative of e to the 2x is 2e to the 2x, which you have the e to the 2x, you don't have the 2, so you're going to have to multiply both sides by a half or divide by 2. So we have a 1/2 adjustment. And then we want to identify, if we know what u is, what's being done to it, what form is it in. This is a du over u, something we would have done in chapter 5. Du over u is a natural log, so you end up with 1/2 the natural log of 1 plus e to the 2x. So that is a review of a u sub and a review of natural log form. The second one is one that I think your initial thought should be, let's let u be what's under the radical, because it's often what we do. But the problem is the derivative of what's under the radical has an x in it, and we don't have one. So we have to come up with an alternate plan. Our alternate plan here is this is actually an inverse trig function. So with our inverse trig function, u is what value of x was squared to get the x squared, which is just x. Du is the derivative, which is just 1 or dx. A is what number was squared to get the 9, so A is 3. We have to figure out which inverse trig it is. We did arcsine, tangent, and secant. Secant is hardly ever used. Arctangent is actually the most common. This one's arcsine. It has a square root, it has subtraction, and the number comes first. Arcsine is the only one that doesn't have a coefficient, so there's nothing in front of arcsine of just x over 3 plus c. So let's look at, here's 4 integrals. They look almost identical. They have all the exact same denominator, but the numerator is different, and talk about what makes them different. What are ones that we can do very quickly? What are ones that need some work? So I'm going to look at the top 2 first, and really you could attack either one first. Ideally, you want u to be the entire denominator. But the problem with that is the derivative has an x in it. It's 2x, which means I can't do that for the first one. But the second one I could do some work with. The first one, since I don't have that du, I need to think again, what's another form? This is actually your arctangent, where your u is x, your du is dx, and your a is 3. Arctangent does have a value in front. It has a 1 over a in front. It also is going to have this 4 in front. So you're going to have a 4/3 in front of your arctangent of x over 3 plus c, which I don't have room to write, but I promise I'm thinking of my plus c's. Now the second one is actually the simplest one on here. I can do my u sub. My du is 2x. I don't have a 2x, I have a 4x. So I'm going to multiply both sides by 2. So my adjustment is actually a times 2 adjustment. And then it is just a du over u, which is, as we just saw a second ago, a natural log. So we get 2 natural log of x squared plus 9. Try to sneak my plus c in there at the end. Then you get to the third one, and the third one is kind of like a combo one. It's a little bit like what we just did. It's got the 4x on top, but it also has a constant on top. So this is another strategy. This is a pretzel problem. So we're going to split this up into 2 pieces of the pretzel, where one piece is going to be what we just did, 4x over x squared plus 9, and the other piece is going to be 1 over x squared plus 9, which is going to be like the one above it. So the first one we already did. We already know that it's 2 natural log of x squared plus 9. And the second part we actually already did as well. It doesn't have a 4 on front. It only has a 1 on the top. So we don't have a 4/3 in front of our arctangent. We just have a 1/3 in front of our arctangent of x over 3. And then finally we get to this last one, which is kind of the oddest one of all of them. With something like this, when you have, this is called an improper fraction, because you have the same degree on the top and bottom. So this is actually one that you need to do long division with, which is kind of a bizarre thing to think about this early. But you're going to take, and you're not dividing by something that has just a linear piece. So you actually have to do a true long division, but it's really short, I promise. So you're going to take 4x squared divided by x squared plus 0x plus 9. And you're going to figure out what do you get when you take 4x squared divided by x squared, which is 4. So you're going to have 4x squared plus no x's plus 9, or sorry, plus 36 when I multiply, 36. Subtract, so you're going to get a remainder of negative 36. So I have a 4 all by itself and the remainder of negative 36. I feel like I need a new, let's see if I can add a screen. I don't know how I do that. So we're going to just come up here and say that I'm integrating 4, and then my remainder of negative 36 is going to be over the original x squared plus 9. The 4, integral of 4 is just 4x, and then this part is another inverse trig. You're going to have a minus 36 on top. You're still going to have the 1 over a in front, so you're going to have a minus 36 over 3, which is a minus 12, and then your arctangent of x over 3, plus c. Again, I promise there's a plus c. So those are 4 very different ways to go about integrals that look almost the same. Disguised forms, kind of like they look like you're not sure what to do with them when you look at them. I'm sure everything right now feels disguised. I'm actually going to start with the number 6 one. So with something like this, especially when you have trig, the first thing I like to do is figure out what's the u going to be. Well, if we have a natural log, it absolutely 100% of the time has to be your u. It's one of our hard and fast rules for u sub. If there's a natural log as part of your integral, it is definitely the u. So the derivative of natural log is the derivative of this sign over this sign. So the derivative of sine is cosine over sine. Derivative of sine is cosine and then over the original. Now, cosine over sine is cotangent. So this is how it's disguised. It's actually a perfect u sub. You have exactly what you need for du, but it didn't really look like it was going to be very good to begin with. So now figuring out what's being done to it, well, it's just a u. The natural log of sine of x has nothing being done to it. It's just u to the first power du. So my integral then is u to the second over 2, which is the natural log of the sine of x all to the second. We could put a second out here, or we could put the 2 after the n, over 2 plus c. I'm getting really lazy on my plus c's. I'm still going to go out of order here. I'm going to do number 7 next. Something that you have to do often with trig, if you can't do a nice u sub, like for this one, I'd really want u to be just like 2x, but the problem is I don't know the integral of tangent squared. It's not one of my known integrals. You should know how to integrate sine. You should know how to integrate cosine. You should know how to integrate secant squared or secant tangent. This is not one of them. This is actually an identity, and it is an identity that you should have a little bit of familiarity with. The identity is that 1 plus tangent squared equals secant squared. It's one of our Pythagorean identities. So tangent squared is actually equivalent to secant squared minus 1. So this is actually secant squared 2x minus 1. There are not a lot of identities that you should know. You should know reciprocal identities. You should know basic Pythagorean identities. And that's about it. So the integral of secant squared I actually know. I know the integral of secant squared is tangent. However, you do have to do kind of a little u sub you can do off to the side. If you let u be 2x, your angle, derivative is 2, so you will have a 1/2 adjustment. So you get 1/2 the tangent of 2x. And then the integral of minus 1 is minus x plus c. The top one is just completely bizarre. If you try to do a u sub, the only thing you'd really try is the denominator, but the problem is the derivative of e is also e, and you don't have that there. So this is one where you kind of want to get really creative and think, what do I wish was there? What do I wish that I had in the top so that my top and bottom could work well together? And what I wish was there is I wish there was an e to the x. I am allowed to write plus e to the x if I also subtract that same thing. I can't do it on the bottom. You cannot take a fraction and add 5 to the top and 5 to the bottom and think that you did something legal. But if I add something, I can turn around and subtract it. So now, this one's a very strange one. I wish this whole thing was an integral because that would be easy to work with. But I also could do something with the leftovers. So this is a pretzel problem. You are going to have a 1 plus e to the x over 1 plus e to the x. That's like the first half of the pretzel. And then you're going to have a minus e to the x over 1 plus e to the x. That's the second part of the pretzel. So your first part of your pretzel, 1 plus e to the x over 1 plus e to the x, is just 1. So you are truly integrating just 1, which is x. This part, this is your u sub. If you let u be the bottom, which is what you really wanted to do all along, the derivative of that is just e to the x. So you have the u on the bottom, you have the du on the top, so you end up with just a natural log. It is negative because of the subtraction sign. So messy, I'm sorry. It's natural log of 1 plus e to the x plus c. So we had some strategies, and I just want to kind of talk you through. These are some things that you would have done in Calc 1 to evaluate integrals. The nice thing on the AP test, they don't get super crazy with a lot of these. So there are a few that are pretty common, and then there are many that are very rare to see. The first strategy is you can expand. You can distribute, you can square, you can multiply it out. And that's going to happen if it's something of very low power or something really easy algebra to clean up. Second strategy, which we do a lot, first and second strategies are really common, is we can split it up the numerator and break it into, we call it pretzeling, and then each piece of the pretzel is separate. Those two strategies happen a ton. My third strategy, not very common, something we would have done at the end of last year, is we could complete the square. It only happens with inverse tangent. It only happens when you have a denominator that is a trinomial that is not factorable, and we're then take whatever this middle term is, cut it in half and square it. That tells me what I need to complete the square. And then whatever's left over, like for that one, I need 4 to complete the square. You can see all my work down here. So that means I have 16 left over, and I let u be my variable piece that was being squared. A is my numeric piece that's being squared, and I get an arctangent. That one is really specific just to that situation. Other strategies, the long division, that's going to be something we do anytime the degrees are either the same or a bigger degree on top. Not very common technique either. It's very specific to that type of problem. And you usually end up with multiple pieces. Usually natural logs show up with those. The fifth strategy is something we just did where we want something to be in the numerator as another term, so we can add that term in and then we can also subtract it. This one's also not very common. And then the last strategy is pretty common, and it's anything with trig. If there's an identity, basic identity we can use to make it easier or make it possible to integrate, that one's a little more common. I would say of your different techniques, the first two strategies and the last strategy are the ones you're going to do the most. So looking at some examples, and you can ignore these numbers. These are just problems that I took from a book. That's where that comes from. And just looking at some different types, just getting some practice. It is so tempting on this first one to distribute. I know everybody is kind of programmed to do that. If it's separated with parentheses, there's probably a reason for that. And it's usually because what's in the parentheses or what's like next to it needs to be the u piece. So that's how we're going to start. We're going to let u be what's in the parentheses. The derivative of that, so this is, think of this as negative 2x to the 1/2. So the derivative is power out front, power 1 less. So when I bring the power out front, it's going to be a negative 1. X to the power 1 less would be negative 1/2, or negative 1 over the square root of x, which you have, except for you don't have the negative. So it's just a negative adjustment. The form of this is going to be a du over u. So this is going to be a negative natural log of 1. I don't know what I just hit. Back to my Jamboard, back to it. There we go. Sorry. 1 minus 2. 1 minus, now I don't want to write. Hello. Maybe that didn't like that. Now all of a sudden my pen. 1. Oh, now I'm red. Who knows? Minus 2 square root of x plus c. I have no idea how I ended up red. Well, if that's the case, we're going purple. All right, so next one is going to be, can be done a couple ways. Probably the easiest way is to do a long division, and it's a really short long division. I want to multiply, that sounds so strange, short long division. I want to divide x squared by x minus 1. X squared divided by x is x. Multiply, I get x squared minus x. Subtract, I end up getting a when I subtract, I have a positive x, and then I just bring down a 0, and then I want to know what I get when I take x divided by x. I get 1. So when I multiply, I get x minus 1. Change signs. There's my remainder. I feel like I have no work left, so I just turned this into x plus 1 with a remainder of 1 over x minus 1. So I get x squared over 2 plus x plus the natural log of x minus 1. I think I'm going to stop now, make this part 1 of the video, and then go back and finish this video in a second, just because this video is getting kind of long.